Let's change the question of writing a quadratic equation slightly. And in this video, we're going to look at what if our solutions, the roots of the quadratic equation, have to be irrational. We haven't solved a ton of equations like this through the process of factoring, truth be told, because factoring is not really designed to solve equations that have these kinds of roots. In these situations, we would have used the quadratic formula. That probably would have been a more effective and efficient way to do that. But that doesn't mean that we can't use the principles of the zero product property to still solve these equations. So if we know that negative 3 root 5 and positive 3 root 5 are both solutions to this equation, we can begin our work with those same kind of factors. X plus 3 root 5 is equal to 0. We'll have that solution. And x minus 3 root 5 is equal to 0. We'll have that solution. There's nothing to multiply here to clear out any fractions. We're not worried about that for this example. So we can jump right to the product of these two factors equaling 0. Multiplying this out, we're going to hope that some of this radical business resolves itself. And the truth is that it will. We will see a cancellation in the middle that's going to leave us with a much simpler quadratic equation. So let's multiply this out. We have x squared minus 3 root 5x plus 3 root 5x minus 9 times 5. And that comes from the 3 root 5 times 3 root 5. Like I said, we're going to get a cancellation here and here, leaving us with just x squared minus 45 is equal to 0. If you're not convinced of your solution, it turns out that this is a nice one that you could check with the square root method. X squared is equal to 45. X is equal to root 9, root 5, 3 root plus minus 3 root 5, which is exactly the solutions that we started with. So again, 2 lessons ago, we would have started here and worked our way in that direction. Would we have seen all of this? No, because our factoring techniques didn't allow us to create irrational numbers inside of those factors. But we have an alternative to get there, the square root method, that allows us to see those same 2 solutions. And just as we expected, we expect these 2 solutions to be opposites of one another, thanks to the quadratic formula and the plus minus that we would see in there. So let's look at a similar example, except this time the solution is a binomial. And as you might imagine, it's not going to change our work at all. We're going to start with a factor. And for the sake of space, I'm going to jump right to the solution version of this, or the quadratic version of this, excuse me, where we make sure we can fit everything. 1 plus 3 root 2, all of that is equal to 0. So this factor gives me that solution, and this factor gives me that solution. Running those minus signs through the parentheses in an effort to clean this up a little bit, we have x minus 1 plus 3 root 2 and x minus 1 minus 3 root 2, making sure they are not identical factors because they shouldn't be. There's no repeated root in this question. Now we run into a tricky spot. There's a couple different ways that you can attack this. You can attack this by treating this as a difference of squares factorization. So here we have the same factor plus 3 root 2 and minus 3 root 2. So you could jump right to a difference of squares factorization. I'm not a big fan of that strategy because I think that's one of those things that you might only remember because a teacher reminded you of it. If you hold on to our strategy from before, which was just multiplying this thing out, that's going to work in every single one of the cases. So while it's going to create 9 terms, I have a trinomial times a trinomial, and it might be a pain in the neck to try to keep everything organized. It's better than trying to memorize the unique situations that might come up. If we know that we just have to multiply this, then we're going to multiply it. So let's just run the multiplication straight across. The x from the first parentheses multiplied by everything in the second one. Then the negative 1 in the first parentheses multiplied by everything in the second parentheses. That's just going to result in sign changes. And then the 3 root 2 times everybody in the second parentheses, plus 3 root 2x minus 3 root 2 minus 9 root 4. And our goal is going to be to simplify all of this. Now, because we know we're creating a quadratic equation, this term's not going anywhere. He's part of the solution. I see an x here, a minus x here, and a minus x here. That's going to create minus 2x. And then from the rest of it, we're going to get a lot of canceling. 3 root 2 and negative 3 root 2, negative 3 root 2x, positive 3 root 2x. And then we're left with just this guy over here at the end and the 1 that we need to put together. 9 root 4 is really 9 times 2, which is 18. That's a negative 18. Plus this 1 makes negative 17. And we have an answer of 0. So the solution is not the path we take to write the quadratic equation. And again, I shouldn't say the quadratic equation, a quadratic equation that has these roots. The path we take is identical to the path we would have taken if it was just a rational solution. We write our factor that has those two as the solutions. We multiply out, we simplify what we need to simplify, and we're left with a quadratic. And of course, we could always go to multiplying to test our work and test our answer.